Good evening. My name is Shebi Samson. I'm the tutor for this course, Human Computer Interaction, CSC 206. This is section 1 of the course, and I'm going to take you through when we say human interactions, HCI, what you understand by it or what we mean by it. I'm going to take you through it. And most of the things that I will be mentioning in the course of this course are more or less interwoven. There are things that I've mentioned in other courses or similar things that we have come across in other courses, but you need to be patient so that you can understand it. The purpose of this course is for you to have grand knowledge of everything that has to do with computer and the interactions. Human computer interaction is a 2-unit course for students in computer science, and the course is divided into 8 modules. Then, and 22 study units, with the exception of some embedded software and operating system code. The success of the software product is determined by the human who use those products. This course presents theoretical and practical approach to making successful and usable software. A user-centered design process as taught in earlier years of triples and experience in many group design projects provide a professional resource to creating software with functionality that users need. Software that is usable for its purposes is sometimes described by programmers as intuitive and powerful, efficient, and effective. These terms are vague and unscientific, but they point in the right direction. This course presents scientific approach to making software that is intuitive and powerful, and at the end of this course, it is expected that you should be able to understand and explain the adequate, equipped, and comprehensive knowledge of HCI, and can try hands in some creative design of software product of your own. The course objective. The objective of this course is one of it is for the student to be able to understand various concepts of ACI, design, concept, theories and practice. Then number 2 is to understand user perspective of human interactions. ACI, cognitive human trust oriented perspective. ACI also improving the user technological perspective and device technological perspective interaction style. And other thing is for the student to be able to understand design of human computer interaction, guideline, rules and principles, evaluations method, and participatory design system, interactive design pattern, test and gesture interaction, evolution of interaction hardware, measurement and assessment of novel method, and students will be able to also understand principle of direct manipulation and interface mode. Then one of the objectives is also for the student to be able to design of user and system interface, design of user's concept, principle and criteria and rationale user interface design programming. And for students to be also inference. In simple terms, students will be able to understand what the system is doing and to know what they need to do using the normal principle of gov evaluation and gov execution, using Bayesian strategies for data entry and programming by examples. So these are course objectives. But in this section 1, Unit 1, by the end of this lecture, we expect students to be able to understand the concept of human-computer interaction, explain the goal of human-computer interaction research and study, explain human-computer interaction techniques, and understand the history and paradigm of human-computer interaction. So, when we say ACI, what do we mean by it? How do you define HCI, computer, human-computer interaction. How do you define it? And when you are, the following definitions are available in different texts, and you can also find additional information online regarding the course. Human-computer interaction is a discipline concerned with design, evaluations, and implementation of interactive computing systems for human use, and with the study of major phenomena in surrounding them. That is, their interest is for them to be able to design and evaluate and implement an interactive computer system for human use, with the aim of phenomena that is surrounding us. So most of the things that human need, most of the activities that happen around human, the aim of ACI is to design and evaluate and implement a system that will interact with the surroundings and human environment. Because of the interaction that occur between users and computer at the interface of software and hardware, such as between computer peripheral and large-scale mechanical systems in aircraft or power plant. Human-computer interaction is the study of that interaction between people, otherwise called users, and computer. It can also be regarded as the intersection of computer science, behavioral science, design, and several other fields. Meaning that the interaction with several other fields and computer science is the purpose of this course. And we know we refer to most of the client user, we refer to them user, but they are human who interact directly with computer at different sector, at different industry. So the aim is to design a system that will enhance that interaction between them. So, overview. Since computer interaction studies a human and a machine in conjunction, it draws from supporting knowledge on both the machine and human side. On the machine side, techniques in computer graphics, operating system, programming language, and development environments are relevant. On the human side, communication, theory, graphics, and industrial design discipline, linguistics, social science, cognitive psychology, and human performance are also relevant. In engineering and design methods are also relevant. These three key areas are relevant in designing ACI. The multidisciplinary nature of ACI enables people with different backgrounds contribute to its success. ACI is also sometimes referred to as man-machine interaction (MMI) or computer-human interaction (CHI). So meaning that we can also have another name for ACI called man-machine interaction or computer-human interaction, which is CHI. The goal of ACI study, meaning the purpose of we studying HCI, is a basic goal of ACI is to study, improve the interaction between user and computer by making computer more usable and receptive to user need in the following way. Methodologies and processes for designing interface in their relative styles. Given a task and a class of users, design the best possible interface within given constraints. Optimizing for a desired property such as learning ability or efficiency of use. Method or techniques for implementing interface, software toolkit and library efficient algorithm. Techniques for evaluating and comparing interface. developing new interface and interacting techniques, developing descriptive and predictive model and theory of interactions. Developing descriptive and predictive model and theory of interaction design systems that minimize barrier between human cognitive model of what they want to accomplish and computer understanding of the user. Then research. Part of research in human-computer interaction involves exploring easier to learn or more efficient interaction techniques for common computing tasks. These include inventing new techniques and comparing existing techniques using the scientific method as follows: designing a graphical user interface and web interface, developing new design methodology, experimenting with the hardware devices, prototyping new software system, then exploring new paradigm for interaction and developing model and theory of what? Interaction. These are very, very key and very essential when you are designing, when you start to design an HCI. These are scientific and technical methods that you need to explore to be able to do such. So now, interaction techniques. Interaction techniques. An interaction techniques or a user interface techniques is a combination of input and output consisting of hardware and software elements that provide a way of computer user to accomplish a simple task. For example, one can go back to the previously visited page on a web browser by either clicking a button or hitting a key, performing a mouse gesture, or altering a speech command. The computing perspective of interaction techniques. Here, an interaction techniques involve one or several physical input devices, including a piece of code which interprets user input into high-level commands, possibly producing user feedback, and one or several physical output devices. Consider, for example, the process of deleting a file using a contextual menu. This first requires a mouse and a screen input-output devices. Then, a piece of code needs to paint the contextual menu on the screen and animated the selection when the mouse moves. User feedback. The software also needs to send a command to the file system when the user clicks on the delete item. So, interaction style. Are you there? The interaction techniques that share the same metaphor or design principle can be seen as belonging to the same interaction style. Examples are command line and direct manipulation user interface. More details are provided in subsequent chapter of this guide. Paradigm and the history. Paradigms are predominantly theoretical framework or scientific worldviews, such as the Aristotelian, Newtonian, and Einsteinian relativity paradigm in physics. Understanding HCI history is likely about understanding a series of paradigm shifts. The study of paradigm is concerned about how an interactive system is developed and how that usability can be demonstrated or measured to ensure its usability. What they are simply saying is that We should follow what Aristotle, Newton, Einstein have done in physics, and how those discovery or invention has evolved over the year. So the same thing goes to the way and manner in which we are going to understand evolution of the HCI and how the paradigm shift over the year historically. So, paradigm of interaction conceptualize the human-computer relationship. Some of these paradigm shifts can be batch processing, time sharing. We said it as this were also discussed in other courses. Time sharing network graphic display microprocessor, World Wide Web, then ubiquitous computing. While outlining arrival of all new technologies, creating a new perception of the trace in history of interactive technology as follows. The initial paradigm started with batch processing that signified impersonal computing and interactive. The paradigm shift commenced from time-sharing processing systems that signify computing. So these are some of the pictorial representation of the shift as illustrated in the diagram or in the figure that is displayed on this slide. You can see in-person computing, then move to interactive computing, then community computing, then we move to direct manipulation, personal computing, then global information, vis-a-vis how those things evolve over the years. So you can only understand that the World Wide Web, for example, turned the world into a global village by creating an example of another environment for a global in the life of educated information access and transmission. This represents a significant paradigm shift from human all over the world. World Wide Web made information from all over the world to be accessible to every user in every location they found themselves. So you look at that paradigm, a computer that started from lab that became a PC, from there shift to global accessibility. So you have to understand, and all these things is necessary because of human-computer interactions, how human relates with system and how and what relates with system vis-a-vis their environment. Then ubiquitous computing can be regarded as another paradigm shift, as it is presently a symbiosis of physical and electronic world in service of every activities. Look at it. So the World Wide Web, the apertures or as originated realized was a closed system. It comprises system universal protocol, that is HTTP, and markup language HTML that make publishing and accessing easy. It allows emancipation of critical mass of users that led to a complete transformation of our information economy. Applying aperture technology to browser allow one to traverse a link across the world with a click of mouse. Now, mouse. The mouse was developed at Stanford Research Laboratory in 1965 as part of the NLS project to be a cheap replacement for light pen which had been used at least since 1954. Many of these current uses of the mouse were demonstrated by the Dutch Egebers as part of NLS in a movie created in 1968. Then we have the drawing program. Much of this current technology was demonstrated at Sutherland in 1963. Sketchpad system. The use of a mouse for graphic was demonstrated in NLS in 1965. In 1968, Ken Poffer and Grant Bedford at the National Research Council of Canada built a mouse out of wood pattern after Egebert and used it with a keyframe animation system to draw all the frame of the movie. Then text editing. In 1962 at the Stanford Lab 2, Egebert proposed and later implemented a word processor with automatic word wrap, search and replace, user-definable micro-scrolling text, and command to move, copy, and delete character, word, or block of text. Cyrus Park Bravo was the first "what you see is what you get" editor formatter developed in 1974. It was designed by Butler Lawson and Charles Simon, who had started working on those concepts around 1970 while at Berkeley. The first commercial "what you see is what you get" editor were the Star, Listen Wright, and then Mark Wright. Then we have the spreadsheet. The initial spreadsheet was VisiCalc, which was developed by Frankton and Berkeley between 1977 and 1978 for the Apple II while they were students at MIT and the Harvard Business School. The software was based on the dependency-directed backtracking algorithm by Solzima and Stormer at the MIT AI Lab. Computer-aided design card, the same 1963 conference, was presented, also contained a number of card systems, including Doug Rowe's computer-aided design project at MIT in Electronic Systems Lab and Conborg at MIT and Sketchpad, and Timothy Johnson pioneering work on the interactive 3D card system. Sketchpad 3 was his 1963 MIT MS thesis. So, video game. This first graphical video game was probably a space war by Slug Russell of MIT in 1962 for the PDP-1, including the first computer joystick. The earlier computer adventure game was created by Will Crowder at BBN, and Don Wood developed this into a more sophisticated adventure game at Stanford in 1966. Koei Game of Life was implemented on computer at MIT and Stanford in 1970. Then we have gesture recognition. This first pen-based input device, the round tablet, was funded by ARPA's Sketchpad. Used light pen gesture in 1963. Thelma in 1964 developed the first trainable gesture recognized. A very early demonstration of gesture recognition was then. We have the multimedia. The same thing goes to 3D. So you can read that more on your book. Then we have virtual reality and augmented reality. The original work of virtual reality was performed by Avant Sutherland when it was at Harvard between 1965 and 1968. Computer Stanford Cooperative Work, Dodge, Egerman 1968 demonstrated of NLS, including the remote participation of multiple people in various sites. Then natural language. This fundamental research for speech and natural language to understand the generation has been performed at CNU, MIS, CBBN, IBM, AT&T, Bell Lab, and Bellcom. Much of it government funded. Then we have our UIMIS and toolkit. We have the interface builder, we have component architecture, we have multimodality, we have agent-based, then we have ubiquitous computing, sensor-based and context awareness interaction, and then we have the metaphor. All these things, you read them up in your main material. So, when we say ubiquitous computing, one example of ubiquitous computing is the ubiquitous graphical interface used by Microsoft Windows in 1995, which is based on Macintosh, which is based on work at Xerox PARC, which in turn is based on early research at the Stanford Research Laboratory, now SRI, at the Massachusetts Institute of Technology. Virtually all the software written today employ user interface toolkit and interface builder and concepts which were developed first at the university. The sensor-based and context awareness. Humans are good at recognizing the context of a situation and reacting appropriately. They are also good at automatically sensing physical phenomena, light, temperature, location, identity, becoming easier through sensor utilized the concept of sensing or physical measures to interactions that behave as if made aware of its surroundings. So they build it around the concept of human being who naturally interact with their environment with light, temperature, and location and identity. Then that takes us to metaphor. The logo turtle dragging its tail enable an effective teaching techniques with file management on the office desktop. Word processing for typing and financial analysis use the spreadsheet. The problem with metaphor are that some tasks do not fit into a given metaphor, while some can be culturally biased. So in summary, human-computer interaction is the interaction between computer users and its interface of software and hardware. Its study requires the knowledge of computer graphics, operating system, programming language, cognitive psychology, and human performance, among others. The study of ACL paradigm concepts concerns its development, while the history concerns the understanding of the paradigm shift. The paradigms are predominantly theoretical frameworks or scientific worldview. The unit has looked at the concept and technique of ACI, the history of paradigm shift, the history of basic interaction, and the personality behind the innovation of ACI. With this, we have come to the end of this class. Thanks you for listening. We'll meet in our next